Hello everyone and welcome to STEM School. So today we'll be looking at rationalizing the denominator, which is the most common exam question you'll get on the Surds topic. So I'll explain how to tackle this with some exam questions, and be sure to check my Rules of Surds video as that explains all the other techniques for the Surds topic. Alright, so rationalizing the denominator simply means to turn the surd or surd expression in the denominator into a whole number. And the reason why we'll do this is because practically it's just more awkward to deal with fractions that have surds in the denominator. So we just want to get rid of that basically. Now, there's two different types of questions you'll be hit with in the exam. The first type is when the denominator contains a single surd. So a single surd like 5 over root 3 or 6 over root 2, something like that. And the other type, and the more complicated type you could be hit with, is when the denominator is an expression containing a surd. So we can have 5 over 2 plus root 3, or we could have 6 all over 7 take away root 2. And the last thing to note is that the numerators can be anything. They'll make the questions more complicated by adding surds there too. So we'll have a go at some questions now, and the method for both types are actually very similar. So let's start with the first type, where you have a single surd in the denominator. All you have to do is multiply the top and bottom of the fraction by the surd that is in the denominator. Then after that, you have to simplify if it's possible. So let's have a go at this question. We've got 9 over root 6. It's easier to understand this with an example. So using this rule, what we have to do is multiply the top and bottom of the fraction by the surd in the denominator. So you multiply root 6 all over root 6. And what I want you to appreciate is that you're essentially just multiplying this fraction by 1. So you're not actually changing it, you're just replacing the surd in the bottom, okay, to make it look nicer. So let's evaluate this. So what you'll get is 9 root 6 all over, then root 6 multiplied by root 6. So this is where you use rule 2 of the rules of surds. So you have the same surd multiplying each other, so you'll just get 6, okay? Now you ask yourself, can I simplify this? So we can have a common factor of 3 for the 9 and the 6. So when you simplify this down, it'll be 3 root 6 all over 2 is the final answer. Okay, so always ask yourself, can I simplify? Now, let's have a go at this question. We have root 2 divided by root 40. So they made it a little bit harder by including a surd in the numerator as well. But it's the exact same process, you just have to multiply it by the surd in the denominator. So root 40 divided by root 40. And let's evaluate this. So root 2 multiplied by root 40, we have to use rule 1 here. So 2 times 40 is 80, then we put that in a square root. And then the denominator is root 40 multiplied by root 40. So the same surd multiplying each other, that's rule 2, so that'll just be 40, okay? Now, we have to simplify this. We've got a big number in the surd, so it implies we need to simplify the surd, right? So we ask ourselves, what square number multiplied by any other number makes a number in the square root? So I know the square number of 16 can be used, and 16 times 5 is equal to 80. So we can replace root 80 in this with the rule 1 form. So we can say root 80 is the same as writing root 16 multiplied by root 5 all over 40. Okay, then we simplify it down as normal. So root 16 is 4, root 5 divided by 40. Then we can simplify this down. So this will just be root 5 all over 10 as a final answer. And finally, we'll do some questions on the type 2, when there's a surd expression in the denominator. And very similar to before, to rationalise this, we have to multiply the top and bottom of the fraction by the surd expression. But here you just need to remember that you need to change the signs. Okay, so let's have a go at this question. We have 5 all over 3 minus root 2. So we multiply by the third expression, but we change this sign, so 3 plus root 2, okay? And then here we just have to multiply it, so it'll be 5 multiplied by 3 plus root 2. And that'll be all over, double brackets this time, we've got 3 minus root 2, 3 plus root 2. So let's multiply out these brackets, okay? So it'll be 15 plus 5 root 2. And then to multiply out double brackets, we use the FOIL method, of course. So this will be 3 times 3 is 9. Then we have plus 3 root 2 minus 3 root 2. And here what we're doing is we have minus root 2 multiplied by root 2. This is where we have to use rule 2 of the rules of surds. So this will just come to minus 2, okay? So it'll be minus 2 on the end there. And here all we have to do is just to tidy it up. So it'll be 15 plus 5 root 2. And that'll be all over. So 9 take away 2, well that'll be 7. Then 3 root 2 minus 3 root 2, well that will just cancel out as 0. So here is the final answer, as we can't simplify it any further. Alright, so let's move on to this second example here. And they've made it even harder now because they've included a third expression in the numerator as well. But it's the exact same process. All we have to do is multiply it by the third expression with the signs changed. So it'll be 5 minus root 8. All over 5 minus root 8. And then let's multiply it out, so it'll be double brackets of 3 plus root 2, bracket 5 minus root 8. Okay, now let's do the denominator. It'll be bracket 5 plus root 8, bracket 5 minus root 8. And again, we just have to use the FOIL method to multiply out the double brackets, okay? And when we do that, what you'll get is 15 minus 3 root 8 plus 5 root 2 minus, so what we're doing is root 2 multiplied by minus root 8. And that's using rule 1 of the rules of surds. So this will be root 16, but we have a minus in front of it. And that will be minus 4. Okay, so it'll be minus 4 on the end there. Now let's do the denominator. When you multiply out the double brackets, you'll get 25 take away 5 root 8 plus 5 root 8. And then we were doing root 8 multiplied by minus root 8. So we're using the rule 1 of the rules of surds, okay? So this will just be 64. But we have a minus in front of it, so that'll be a minus 8 on the end. Okay? So same as before, we just have to tidy it up. 15 take away 4, that'll be 11. So we have minus 3 root 8 plus 5 root 2. Okay, let's tidy up the denominator now. So it'll be 25 take away 8, that'll just be 17. Minus 5 root 8 plus 5 root 8, so we've cancelled them out, that will be 0. Now, is this the final answer? Well, no it isn't, because if you look closely at this root 8 here, we can see that we can actually cancel this down. And realistically, this is where people that would have lost marks, this is the step where they would have lost the marks, okay? So I know that I can break the root 8 down into the square number of 4 times 2. So we can rewrite root 8 as root 4 times root 2. Okay, using the rule 1 form. So I talked about simplifying surds in my previous video, right? So let's rewrite it. So it'll be 11 minus, so I'll write 3 and then in brackets I'll say rewrite root 8 in the form of root 4 multiplied by root 2. Then we have positive 5 root 2 on the end. Then we have all over denominator of 17. Okay, so let's times out this bracket. So we have 11, so root 4 is 2, so it'll be minus 3 2 root 2. Okay, plus 5 root 2 all over 17. So we're nearly there, right? So it'll be 11, so multiply it out, it'll be minus 6 root 2 plus 5 root 2 all over 17. And here we can see that we've got two like surds. So when we have two like surds, this means that we can add or subtract them. I talked about that in my previous videos, alright? So if you think about it like algebra, what this is like minus 6x plus 5x. So it'll be 11 take away root 2 all over 17 as the final answer. Just imagine a 1 in front of the root 2, okay? So that's the final answer. Okay everyone, we finished on a tough example there. Be sure to check out my next video, which will be on the rules of indices. And as always, please do like and subscribe, and I'll see you in the next video.